Kasaj topological spaces. Kasaj, or maybe Kasaj topological spaces were introduced by Kashyap Raj and Sajid Ganji in 2020. So this specific and rather original name, Kasaj, perhaps it comes from their names, Kashyap and Sajid. To speak about their concept, we should start from the more general idea, namely the idea of nano-topological spaces, which were defined several years ago by Lelis Tivagar. And moreover, we shall mention Chandrasekhar's micro-topological spaces too, but you should know that all these constructions are connected with the general idea of rough sets, which have been invented a few decades ago by Polish scientist Pawlak. For example, the notions of lower and upper approximation are taken strictly from this theory. And moreover, you should know that you may find a video on my channel about so-called generalized approximation spaces, which are generalized version of approximation spaces as they are defined here. Let us start. Assume that we have a non-empty universe of discourse, which is called U, and R, which is an equivalence relation in U. And this pair UR is called an approximation space. If R is not equivalence relation but weaker relation, then you may speak about generalized approximation spaces. But here we have an equivalence relation. And assume that we have some certain set X in this universe, contained in this universe. And for any X in our universe, we have Rx, R equivalence class of R element. Then we may define the lower approximation of X with respect to the relation R as the union of all those elements, maybe not of all those elements, the union of all those equivalence classes of those elements such that equivalence class of this element is wholly contained in X. Then we have the upper approximation. The idea is similar: to sum up all the equivalence classes such that and this is weaker condition, that Rx and X have non-empty intersection. Rx need not to be contained in X here, but it should have non-empty intersection. And then we have the boundary region, which is the set difference of those two sets, U upper approximation minus lower approximation. And now Tivagar observed that if we define this family, the whole universe, the empty set, lower and upper approximation, and boundary set, then it appears that this family satisfies all the axioms of topology. So there are only 5 elements in this family, and this family forms topology. For example, the whole universe and the empty set are in this family, and one can prove, one can check that there is closure under arbitrary unions and at least finite intersections. And this family is called nano-topological space, of course with respect to some universe U, a relation R, and set X. Then we have Chandrasekhar's micro-topological spaces. They rely on the notion of nano-topological space. If we have nano-topological space, then we may consider the following family. As you can see, take any two sets K and K prime from the nanotopology. So for any pair K prime, which can be established, take some fixed X which is beyond this nanotopology, and then calculate this expression, the union of K and the intersection of K prime and S. And again, it appears that this family, the family of such constructions, it satisfies all the actions of topology, and we call it micro-topological space. If you are interested, then here you have two examples given by Chandrasekhar. Of course, there is no time here to analyze them in details, but of course you may stop the video here and you may check if these calculations are correct, and you may wonder upon this concept. And this idea has been developed by Chandrasekhar, and now there are several papers on micro-topological spaces about ideals and grills and weakly open sets in micro-topological spaces and so on. And then we have Kasaj topological spaces. It seems that there are only 3 papers about Kasaj topological spaces nowadays. The idea is more complex than in the case of micro-topological spaces. Again, we start from nano-topology, like here, and now consider the following family. As you can see, take 2 fixed S and S prime, which are not in the nano-topological family. Here we have the assumption that the union of S and S prime should give us the whole universe, and there is no any requirement that they should have empty intersection, that S prime should be complement of S. But it seems that all the examples given by those authors are based on this assumption, but it's not strictly written in their papers, so I'm not sure if S prime is a complement of S or not, not necessarily. Be as it may, then we have the following construction. Take the union of K and S plus some K prime, where both K and K prime are nano-open, with S prime, and calculate all such expressions, and this family we may believe that it has all the properties of topology. So here you have an example. Again, this is taken from their original paper, which has been published in Malaya Journal of Mathematics. And here you can check if all those calculations are true. And for such, this is a mistake here, for such U, such universe U, this is not X but U, for such relation R, and for such distinguished X, they obtain the following nanotopology. Here they have only 3 elements, because it's possible that lower and upper and boundary approximation are the same, for example. And then they take those 2 sets S and S prime, which have empty intersection, as you can see, and then they calculate their Kasaj topological family. Well, of course, they define several basic notions like Kasaj closure and Kasaj interior. Of course, the elements of Kasaj topology are Kasaj open sets, their complements are Kasaj closed, and so on. These 2 definitions are also very typical for any topological or even generalized topological space. And the authors declared that some basic theorems are true. I said that they declared because there is no proof in their paper. They gave those properties in a kind of definition. So if you are interested, you may check all those properties if they are actually true. Moreover, here we have that interior of an intersection is contained in intersection of interiors, and that's okay, but in topological spaces you may replace this with equality. The same here, where you have that the union of closures is contained in the closure of union. Again, in topological space, not necessarily in minimal structure, for example, or infra-topological space, but in topology, you may replace this with equality. So you should check all those properties. And of course, as always, they define several special subclasses, just like in other topological and various generalized topological spaces. Namely, pre-open sets. A is pre-open if it's contained in the interior of its closure. Semi-open. Now we have contained in the closure of its interior. Generalized closed sets, as you can see here. B-open sets. Regular open sets. And of course, the notion of continuity has been defined for Kasaj topologies, both for standard Kasaj open sets and for those classes which have been mentioned here. Here we have the bibliography. This is the seminal paper on Kasaj topological spaces. These are two other papers by the same authors, together with Mr. Soneggi. And here you have some papers on micro-topological spaces and about nano-topologies. Thank you very much for your attention and goodbye.